Hi, this is Coach Judith. This is the second half of the response to Stephen's episode about debugging, his process for creating videos for the coding versus COVID-19 series. We are halfway through watching his video, and just a little background if you didn't see the first half. He had a problem rendering the second minute of the video he was trying to create the day before he created this video. And so he decided to create this video that we're watching to talk about the debugging process and how he is trying to figure out what is wrong with minute 2. What we are going to be seeing right on the screen when we get into the movie is the code that he wrote that combines the different clips with visual and audio clips to create a minute. He wrote some code that, because Stephen is a coder, that makes the process more efficient, and each clip is its own illustration. So let's set that up and let's get watching.
That's, by the way, because the camera is mounted on that articulating arm, and because I sit right there facing this way, then the camera above is actually upside down, which is one of the reasons why my program flips things automatically. The illustrations come in as files, they're MOV files off of that camera. My code, this function right here, illustration, or rather this function right here, combine, will take all of those illustrations, all of those video files, and do various things to them. It'll flip them, it'll sharpen it in case I forgot to set up the focus the right way. In some cases, it'll mute it so that I don't get background noise from my illustration tracks. Various things like that.
So just to help you understand what Steven's talking about, so he is taking these little movies with his very fancy camera that he has stuck there, hanging off of that what he called articulating arm, and the name of each of these little clips, giving speech and say students forever. Teachers and theirs, etc. He wrote this software called Illustration that makes those clips look better so that when he puts them into Shotcut, which is the program that is creating these videos, he can use those little clips along with audio that he's overlaying.
All of that saves me a lot of time.
Saving time is what this is all about, trying to be efficient. That is the cool thing about being a coder, is that you can take a lot of different problems, and Stephen is illustrating that in several of his videos. Problems that you might normally do by hand, and use code to speed them up and become more efficient so you can do other things with your time.
It does, and this part I think is working, is that when I run this file, and I can actually do that right now. So if I say Racket, which is a programming language, if I run Racket on Shotcut, it spits out a big XML document.
All right, so Stephen wrote this code. We talked about it in the first half of this episode in a language called Racket, which is a language that is really good at creating other languages. And he created a file that takes his code and creates XML files, which are the files that are needed to go into the Shotcut program that is editing the video.
There, that's the XML document. Now, on a bash prompt, you can pipe anything that spits out of a program into a file. So really, my program is just printing. It's just like printing hello world, except it's printing an XML document.
So when Stephen says that his program is printing, you might be thinking he's printing onto a piece of paper. That's what we normally think of. But in this case, Stephen's software is printing out to the screen. So everything you see here, it is printed out onto the screen. And now he is going to use a command to take what is printed and put it all into a separate file that he can use.
But I can take that XML document and I can pipe it into a file on my computer with this what looks like a greater than symbol, but in this context, in Bash, it's not a greater than symbol. It is a piping of a giant string from one program into a file.
A giant string. You may be thinking he's talking about a piece of string that you could use to play with your cat if you had a cat. I have a cat. But what he is actually talking about is text, is letters and numbers text. That's what he refers to as string.
And so if I wanted to call it example, example.mlt, I could. MLT files are the ones that Shotcut can open. So now that I've done that, I should be able to actually go over here in Shotcut, say open file, go to minute 2, and open up example.mlt. And we should see various illustrations strung together. It looks like that is the case. So we got, I'll skip to the end here. Yeah.
I just want to back this up a little bit to show you what he was trying to show you. So he created this XML file that printed out to the screen, and he put that information into a file called example. Then he opened. This is one screen that he's looking at. This is the other screen. This is where he's running Linux. This is where he's running the Shotcut program. He opened the example file, and then I think it was really quick. Oh, it's right there. You can see we saw back in his Racket program, he was referring to these MOV files called Giving, Speech, and Say, Students Forever. So that is this file that he just opened, has all of those little clips combined into his example file, and now he is reading them into Shotcut. Let's go back to where we were and keep going.
End here, yes. So this is a minute of discussion on the extended mind, wherein, let me full screen, wherein I sort of say what I would say to a group of students, teachers, artists, and engineers about the extended mind. Each of these is a video.
So if you want to learn about the extended mind, this 5-minute video that he is talking about the extended mind, that is the next episode.
Video clip, and it's either sped up or slowed down to fit into the amount of time that it needs to take up in order to align with whatever it is that I'm saying. So all of that pops straight out of the file that defines it, which is this one, to Shotcut. So I define the illustration sequence I want with the lengths of time. Scaling in time happens automatically. Out pops a Shotcut file. Everything seems to be working at this point. In fact, the pipelines seem like they're doing exactly what they're supposed to be doing, but they're not, because, and I don't know why, whenever I try to render this file, it appears to be working for several minutes. But last night, I watched that move up to 100% over and over and over, and then at the very end, each time it would fail.
How many of you have worked on something over and over and over? You don't understand why it's not working. You do it, it seems like it should work, it's not working. So that's what Stephen experienced. That can be a frustrating experience. But one of the things that you need to learn when you become a coder like Stephen is we call it grit, that you just have to keep plugging away to try to figure out how to solve the problem. And even though Stephen spent a lot of time last night working on it, he hasn't yet solved the problem, but he's we are watching him go through the process of trying to solve it. We're looking into his mind here.
And I never got an MP4 file out that I could then place into this Shotcut file right here. So every other one went through that pipeline and got spit out just fine. Minute 2 seems to be stuck somehow, so there's a pipe that is clogged. I wish I could just keep the camera rolling while I debug that, but the thing is, I don't know if that's going to be a good story. I don't know if it'll be interesting, and I suspect it probably won't. I suspect that what will probably happen, and I just say this from past experience, is I'll work on this for a few hours and I'll find out that it's something dumb.
Has that ever happened to you, that you have worked on a problem thinking it's something super, super, super hard? You spend hours and hours and hours working on it, and then it turns out that it's something dumb? That's kind of embarrassing, but you know what? Even really smart people like Stephen, we all go through the same thing. So it's good to hear Stephen admit that even though he may spend a lot of time on it, it could turn out to be something really easy.
Like, like maybe if I just restart my computer, it fixes it. Maybe I'll work on it for several hours and realize it's a subtle bug in my code, so that it was putting out a shortcut file that can be opened in Shotcut but doesn't render. I'm not sure why, but one of the things I'm going to do to try to get traction on the debugging process is that I'm going to use an idea called binary search. So something.
Okay, so binary search is a computer science term. As we watch towards the end of this video, Stephen is going to explain it to you, so I'm not going to define it now.
In this video doesn't render. I don't know what it is. Maybe it's one of these clips. Maybe one of the clips is corrupted. But I don't know which clip is corrupted. So I'm going to use something called binary search. I'll try rendering the first half of the video. If that works, I'll try rendering the next half of the video. If that doesn't work, that tells me that the problem is in the second half of the video. And then I can keep subdividing the second half to try to isolate where the problem is there. If both halves do render, that tells me something else, that it has something to do with the length of the video. But that would be quite puzzling because I've rendered many longer videos. In fact, I render a 5-minute video every day, and this is just a 1-minute video. So that's why my theory right now is that there's some kind of corrupted clip, something wrong with the data.
So Stephen still doesn't know what the problem is, but some of his theories are that perhaps just some piece of one of the little tiny clips that he recorded on his camera is sort of broken. It's corrupted is the word he used. So hopefully that is what it is. The other thing he talked about is using a binary search to figure out where that corrupted clip is. Again, we'll talk about binary searches in a little bit. He did just describe it. But you can see that Stephen is going through this very logical process of trying to figure out where the problem is that is causing this 1 minute of video to not render correctly.
Well, that's it. That's the idea. That's my plan for the day is I'm trying to get this episode out. I'm going to do some debugging. And by the way, what I did just now is some rubber duck debugging. I'm going to give that to you as a homework assignment.
Here's your homework assignment. Figure out what rubber duck debugging means.
Anyone interested in going beyond what I talk about in this show? So rubber duck debugging, Wikipedia article, very short. Extended mind or extended cognition.
So extended cognition is going to be described in another episode, but you can look it up on Wikipedia.
That is the topic of the next episode, the one I'm trying to get through the pipeline. And binary search, that is a technique that is often taught as an algorithm that you have your computer do. But to be perfectly honest, it is a much more useful algorithm for you to know so that you can do it yourself as a human being on a variety of things. I do it all the time. It's a key part of debugging. If I have a piece of software that's 100,000 lines long, it's nice if I can find bugs by slicing it in half and just look at the first half of those lines of code. If I could determine the bug is in that first half or not, then I can keep repeating that process and I keep slicing my program down to a smaller and smaller piece of code where there is likely to be a bug. You do that enough and you isolate the exact line where the bug is, and then you fix it. But the fixing it's the easy part. The finding it is the hard part. And this is an algorithm for searching for things. And it can be used by a person just as well as by a computer. So today...
Okay, so that is the end of the video, but I just want to explain one more time what a binary search is because that is an important concept in computer science. And Stephen even used it out a little bit outside of computer science as a human. So the binary search algorithm, and algorithm is a really big word, but basically it means coming up with the steps that you need to solve a problem. So here's what you do in a binary search. Let's say you have 1 minute of a video that is not rendering correctly. That is Stephen's problem. So he could look at second one, second two, second three, etc., and go through all 60 seconds. But instead, he breaks that 60 seconds down into two halves, 30 seconds each. And he sees, does the first 30-second render? If it does, great. Then does the second 30 seconds render? No, it's broken. Okay, so now we know the problem is in the second half. We have 30 seconds to look at now instead of 60 seconds to look at. We take that 30 seconds of video and we try to render 15 seconds of it. Does the first 15 seconds render? Yes. How about the second 15 seconds? No. Okay, now we know the problem is in the second 15 seconds. So we can throw out that other part. So then you take your 15 seconds of video, you break it down in half again, and you keep breaking it down until you find the actual second where that probably corrupted piece of video is living. And that is the faster way to go through it rather than look at second number 1, second number 2, second number 3, all the way through 60. This way we cut it in half a few times and it's a much quicker process. So that is a binary search. And that concludes the current episode of Quarantine Coding Club. I look forward to seeing you in another episode.